second. Here we go. All right, good. So thank you for having me in your user group, and I hope you will enjoy the little ride that I've prepared for you.
Yes.
I have only one disclaimer. Feel free to interrupt me when you have questions,
Okay.
either in chat or just by speaking out. Since we are not that numerous in the group, I
Yes.
think we can be perfectly, if you feel comfortable, of course, by unmuting yourself and asking a question. Feel free to do so.
Okay.
Maybe a little word about myself. My name is Mike Martin. I am what they call a technical evangelist cloud solution architect for Microsoft. I work in the Belgian sub, but actually I speak all over the world on everything in regards to Azure, most specifically, but also application innovation. I talk about DevSecOps. I talk about security in applications and so on and so on. But my biggest focus and my biggest love actually goes out to Azure. And this is why I'm invited here, because this is an Azure user group, right? So you want to learn about Azure. And by a show of hands, that I think that would be easiest. I think everybody has experience in Azure or not at all. So if you have experience in Azure, just give me a thumbs up if you can. By the reactions, yes, okay. Oh yeah, you have a question, or was it the hand? Was it the thumbs that you wanted to show? Okay, yeah. So everybody's just showing the hands. Yeah, normally you also have a reaction with a thumb, but that's okay. I think it will count as a hands up. All right, good. So if everybody is as experienced, which is good, I'm going to talk to you today about, as you can say by the title, Project Pheno. And Project Pheno is failure is not an option. I'm going to show you, teach you, discuss with you on the tools, the services, and everything that you need to build resiliency and high availability and design for failure when you're designing Azure solutions. And that's the core goal. I have a lot of material in my deck, and the deck itself is about 160 slides big. I probably will not cover all of them because there's also some reading material here, but I will discuss most of the topics with you and see how we can build better for our customers or our products. All right. So let's start off with a little prologue. What is it about? So it's really going back to the roots of real cloud design. So one of the things that are there is when we started off this journey with Azure 14 years ago, and because Azure is was born in 2008 at the PDC. When we talked about cloud, the goal of cloud was actually to have a couple of features available, and the most important features are here on the screen: resiliency, elasticity, scalability, and high availability. Um, and all these concepts, they are actually giving all the benefits which cloud have. And this is where we should be focusing on again. Today, I see way too many customers and partners building non-resilient services. They only focus on setting up one region, not worrying about multi-region deployments, failing over, having a segregation between all the layers. They don't talk about that too much. And I hope that after this session, you get a better idea on what you could actually do and achieve and making your services better. So there's a lot of these kind of drawings inside of my deck. They all refer back to one of my favorite spots on the internet called the Azure Architecture Center. This is one I built. This is the resilient design and the global distributed design for Cosmos DB applications. And there's plenty of more where that came from in the Azure Architecture Center. All the links are in there, so you can just click through on those. Once I will upload the slides, I don't know, I will give them to you afterwards. Maybe I will just upload them here in the session. I'll see how we can handle this. And for the newcomers, welcome for joining me. So when we talk about system building, there's two things that typically are being confused. There's two parts that are very important when we're designing for failure. It's reliability and there's resilience. Now, reliability is the what and resilience is the how. Where reliable means that you maintain a system which stays up with an uptime as high as possible. This is typically your SLA. Where resiliency is, how can I, like a spring, like a spring that you have in a seat or in a suspension, and the springs, if you push them down, they get back up and they actually go back to their original state. This is what resilience is about when we're designing services. You want to make sure that if they fail, they get back up again, and you will actually, as an end user, don't feel that your service went down. So this is a little bit important when we talk about designing for failure. So, and there's another part that comes along with it, which is high availability, making sure that it stays available at no matter what kind of an operation that you're doing. And there's also a little part behind it, but this is not the main focus. This should be an additional thing that you should do, but this shouldn't be your main focus, which is DR, disaster recovery. Because a lot of people say that if you're designing for failure, oh yeah, you just need disaster recovery. It's not the same thing. Disaster recovery is after the fact. It's only when you cannot recover from a failure and that when you don't have that resiliency available. So you need to make sure that you have that, like let's say for databases that need to be backed up, configurations that need to be backed up, applications that need to be backed up, and so on and so on. So some state maybe, this is maybe helping you when it comes down to recovering when everything went down. And last week, I came across a customer partner. They were in the news. It was an organization which had everything on-prem. The company burned down totally, and none of the people were able to restore any of the databases of their ERP system. Why? Not because of the backups have failed, but they've never tested the restore procedure. And what they didn't know was the IT implementer or the IT service integrator didn't have the correct key, encryption key, to restore the databases. So even if your database backup went fine, they still couldn't recover. So disaster recovery is also a part of an operational thing. So you need to keep that in mind. So whenever you're taking backups, make sure that you test them and that you also try to restore them. So DR is after the fact. And the fact here was everything burned down. There was no resiliency. There was no design for failure. They could have easily have everything in the cloud and they could continue operations, but they chose not to, which is a stupid thing, and that's why. But also their disaster recovery didn't work, so they have nothing left, which is, of course, painful. Some other things that have to do with this, but I'll leave this for you reading, just the difference between RTO and RPO. This is some level setting. Now, when we talk about high availability, typically you have the difference between all three. In Azure, we try to strive for high available and resiliency out of the box. We start off with how we design the world, meaning our little world, Azure world. You know that today we have I think it's about 70 almost announced and available Azure data center regions. Only a couple in the African continent. So I'm sorry about that, but that has to do with politics and with availability of power in the internal part of the continent and all these things. So don't shoot me. That's a decision on top of Microsoft. But we have 66 regions that are available that you can use, and more to come. Whether they're sustainably built and so on and so on. Now, the cool thing is that we have a huge backbone, a huge backbone internet connectivity with a dark fiber, steam, undersea connectivity in between continents, and so on and so on. So there's a high available network already at place. But we do a little bit more. That same network can help you in designing, because we added something over the last couple of years, which are called availability zones. And availability zones go beyond just the single data center. They go also inside of multiple data centers. So we have one data center region has multiple availability zones inside of one of the data center buildings. So data center 1, data center 2. And even in there's multiple data center buildings. Yeah? And even inside of the data center buildings, there's multiple availability zones. So we try to make sure that all of these Azure services that we're offering are already highly available, and that they're passing along underneath the covers when something goes down. So what we do here is we try to avoid the data center failure at any cost. But if it does fail, we immediately, by the use of availability zones, we move everything around. So your VMs will start moving, your storage will start moving. Of course, if you chose to use these availability zones. By the end of 2021, we had a pledge that all data centers would be now availability zone enabled. We achieved that. Now it's for the new services to be implemented on those, making sure that we have availability zones for each of the services, but all data centers are now availability zone enabled, giving you the leverage to use and design for a better fail-safe environment. This either works in one single zone, but also multi-geography based. So geo-replication is nothing new, but we can also have availability zones over multi-geos. So that way you have one geo here, one geo there, and they also have the availability zones enabled on both geographies, which is very cool as a feature. If you want to read more about reliability itself and what we're doing there, there's a full set of blog posts and what the things that you can achieve with those. And Mark Rusinovich, our CTO for Azure, he actually has a full series of blog posts describing every single new thing that we're doing inside of reliability. We stepped away from, let's say, for instance, Azure Active Directory, which had a reliability of only 99.9. Today, we are at 99.99 with Azure AAD reliability, because we now have multiple region availability of that service. In the past was just one single region where you could have that as a global service. Today it's a global service divided over multiple regions, so which is a good thing. We added tools like tardigrade. We added tardigrade is a little animal, microscopic animal that can sustain a lot of high temperatures, low temperatures, high pressure, low pressure. So it can actually sustain all of the most gruesome environmental parameters. And we designed our underlying VM infrastructure just that way. So if like Hyper-V goes down, where all Azure services are running on. For those who know how Azure is running, it's all racks with VMs in there, and there's a top rack node, which is actually the service fabric, and the fabric controller, which is running all the operations for your Azure services. But everything else is just VMs, which are being managed in an Azure way, which are exposing Azure services as you need them. Yeah? All these are being moved along in either a predictive or a non-predictive way to get a higher reliability. And one of these things is tardigrade, making sure that there's a little hiccup only disavailability. So because you always have to have that switch in between different services, like for instance, say the underlying infrastructure for one service goes down, you will always have a little hiccup, not the connectivity part, but everything will be replicated, and then you can connect back to the service. That's something that we cannot avoid, but there will be even better ways of doing that. One of these things that we're doing there is the introduction of AI ops. So artificial intelligent operations, where we can actually assess all the critical parameters of an environment and making sure that we have a better customer experience, but that we monitor everything of these parameters. We push them through through all the learning parts, and we push them inside of something we call Project Naraya. And Project Naraya is actually a prediction model that we have based on machine learning that allows us to predict where the services will go down. So there's all these parameters coming in from telemetry and from testing environments, and a couple of other scenarios were born out of this. But this is something which is running today, which we are improving every single day by learning on all the telemetry that we have, meaning that if some of our services are planned to go down, and not by manual interference, but by all parameters that are happening in the telemetry, we can actually now predict when it will go down, and we can actually do counter measuring before that, meaning that we don't have to be resilient, but we can be improving that high availability part here. Yeah, so this is something what we're doing underneath, and there's a lot of more things that we're doing in the data center just to improve that. Now, why am I telling you this? Because all these features that we've implemented inside of Azure to make your services available, like the availability zones, Nadia, and so on, you can actually use for building your own services. Think about service health, to monitor those and making sure that service health can actually help you move over to another environment before you actually get the results back. Take a look at how you build, let's say, for instance, your AKS clusters and making sure that you have multiple availability zones available for that, and so on and so on. So these are the little building blocks that are getting more and more integrated into the Azure services that you're consuming, and not only the ones that we are using to building our services for you. All right, so that's a little bit the setting of the scene. Yeah. Now let's see a little bit on how we can do resilient design when we're talking about multiple facets of solution development. First of all, we're going to talk about migration. There's still a lot of people migrating into the cloud. If you did that already, you know what I'm talking about. If you never experienced a migration program, this will give you some good insights. Then we will talk about greenfield solutions, which is the next chapter. And then afterwards, I'm going to talk about optimizing your operations and talking about pure architectures and DevOps and all these things. This is what we're going to have. Is this sounding all reasonable so far for everybody? Is this something good?
Yes, quite nice.
Okay, good. So again, for the newcomers who came in a little bit later, don't worry about it. We'll not hold it against you. But if you have any remarks, questions, whatever, feel free to either type it into the chat or just unmute yourself and ask the question. I'm not shy to answer any questions or to be interrupted. This is an open discussion. I'm here to share my knowledge with you, not to just be a teacher and just like, you know, that's not the way it works. It's a give and take game. Okay, so let's talk about migration. So typically when we talk about migration, it's only about lift and shift. We have on-premise environments, and we have these. Okay, typically we have client server environments that have been built up over the years. It's legacy, and the bad thing about it is that if you're doing migrations, lift and shift, they always come up with, oh yeah, we need to design our services just the way we did them on-prem. Now, I'm going to tell you a little something, and you will hate me probably for it, but this is not doing cloud. This is just doing rehosting. If you're thinking that you're doing cloud because you did a lift and shift, you're wrong. I hate VMs on every level. VMs are not a scalable option or not a high available option because it involves way too much fondling around, way too much plumbing behind the scenes. And you still need to have all these different services in regards to that. Now, does it mean that it's a full bad design? Not always, but you need to keep into account a couple of things. What you typically have, and this is on VMs very important if we talk about availability within VMs. Today, when we were deploying VMs, we actually also take into account things like fault domains and update domains. So you need to make sure that you have at least 3 VMs running to keep a high available system up and running. Why is that? Because VM1 will be placed in fault domain 0, and then fault domain 1 will be having VM1, and then we also have VM 3, I mean, in fault domain 2, right? A fault domain is typically seen as a rack, where an update domain, which is also very necessary, is when you doing updates yourself or we doing updates on the system, that we have a high availability inside of the same rack, making sure that none of these correlate into each other, and that if you're updating fault domain 0, that fault domain 1 and 2 will not be impacted, and vice versa. So there's always a little bit of interaction there. So this was the way we had that for just for VMs with availabilities. Is now availability zones will improve this, and they also work with fault domains and update domains. But know that there's always a rack and a single blade involved when we're talking about those. So, and the resilience pattern here is we have a 99.95% SLA. Yeah. Even today, we offer an SLA of 99.9 for a single VM, which is not too bad. But again, there's still a lot of things that can go wrong because you still have to patch your VMs, and it always involves the downtime when you're patching them and updating your applications and your environment. So there's a little bit of a bad thing going on. So you always need to have at least 2 deployments of those VMs, your front and your back end, making sure that there's load balancers in between, and it involves a lot of work to maintain those. So there's a high TCO involved, but also a high maintenance and high management cost. Monitoring those and more, how should I put it? There's more gears that can break into your system. So you want to stay away as much as possible from VMs and rather replace most of your services by real services instead of just hosting them into a virtual machine, right? So typically you see these kind of full designs, and if you want to do them in an even more high availability way, you need to deploy everything in double, giving you a high cost, because everything that you do always comes back to a couple of things. And one of the things that are always coming back when you're doing cloud is CDA. And that's not cloud developer advocate, but it's CDA is a term that a friend of mine invented 10 years ago. It's called cost-driven architecture, because you need to implement the cost of your VMs, and you need to keep that into account, right? Because if you have multiple VMs and you have a high workload, which doesn't scale, by the way, because if you need to scale this thing, you need to add manually a VM, you need to onboard that into the load balancer, so you need to script that, making sure that it can be deployed. Adding a VM in scaling takes about 10 minutes before that's being added, and so on and so on. So it's not really fast either. And typically they come with a higher cost because you have a higher load of CPUs, a higher load of memory available, and they come in another SKU, which is more costly. Now, of course, you can say, yeah, but what about reserved instances? We can use those. Sure, but you need to prepay those too. And you only have a limited set when it comes down to capacity planning and so on and so on. So it's kind of a risk when you're doing these. Now, a lot of people just go with, of course, you already have some resilient design here because you're using traffic manager here, you're using DDoS protection to offload some of the volumetric attacks, so that way you will not be throttled there. But that's not really the way you want to do this. So that's wrong with this picture. You're not talking about elasticity here. I mean, we can scale up our VMs. Fine, you can bring them into a higher SKU, but that will involve a downtime. You can scale out, adding additional ones. It will take you a couple of minutes, but of course your system will not suffer downtime, but you will be throttled at that point. So making your resilience factor higher, lower, I mean. So it will be harder to be resilient at a point where it will start failing. So the high availability is also at risk. So you need to keep that in mind. So what you can do here is oh yeah, we can start implementing VM scale sets. Yeah, that's cool, and they're scalable and they're fast, but and there's an ease of management, but it also comes with you need to have a good scripting there, a higher cost because these VMs are there, and there's also some things impacted that your VMs are still, let's say, for instance, if it's things like SQL servers and stuff, they need to be configured the same way. And what about your state of your application? That's also something which is really, really hard. And most of the VM-based applications, they're still using state on a VM. So you need to make sure that that also gets impacted. So some things that you need to do when you're doing migration is have some first steps of improvements. First of all, keep VMs out of scope if you can. Yeah, and maybe use some approaches for something that we call Azure migration projects to be a little bit more different. Today we actually support Windows containers on Windows contains Windows Kubernetes on Windows. So that's supported, and we can move .NET applications immediately into Windows containers and make it in a scalable way. Of course, if your application is not set for sessionless or session state broke, then it will not work, of course, right? If it's a monolith application, try to break it up already, because this is typically where the issue lies. Now, you can have monoliths without breaking them up, and also have them in different layers if you just disable some of the features on that monolith. If everything is in a monolith, but your system is still designed in multi-tiered, which is possible. I mean, all the tiers in the same machine. Well, you need to have multiple environments. If it's .NET Core, you can probably do that in multiple app services, for instance, right? So investigate in layers if it's already an N tier, and try to break it up in pieces. So the easiest way is just moving away the data estate. Look for things like Azure databases. Today, we have a plethora of choices when it comes down to databases, whether it's our full SQL server. Yeah? We're gonna forget about SQL Server and Azure virtual machines, but we're talking about SQL Server databases, either in managed instances or in elastic pools. If you have multiple databases that need to be managed for multiple customers, for instance. We also have all the open source databases which are important inside of the world. We have Postgres, MySQL, MariaDB, and maybe some others might join someday. We never know. I mean, at least I cannot tell you, because there's a lot of people working inside of the Azure databases group. And we also have non-relational databases like in-memory databases, Azure Redis, for instance, which is a full Redis environment available at your disposal, which can be used as an in-memory database. Yeah? Or as Azure Cosmos DB, which has already the advantage of being a full global master database all over the world, which is really, really cool. So you have a plethora of choice. And don't forget, there's also still Azure storage with blob storage or table storage. And if table storage isn't enough, you can just easily move over to Azure Cosmos DB and use the Azure Cosmos DB table storage API, which is the exact API as in Azure Storage, but more scalable and all the features of Cosmos DB at your disposal. So that's the first part. Yeah? And also try to plan, and this is really important, try to plan that your application can also be polyglot persistent. Don't only focus on the one single storage that you know. So don't do what we did in the past with SharePoint, for instance. The earlier versions of SharePoint had all their blobs in the SQL database. Now that kind of worked because SQL supported that, but it also hurts your data estate. And it also hurts the performance of your database if you didn't set it up correctly. So we moved away from that, and now today everything is moved into Azure Storage, in blob storage, with high-speed interactions underneath it. Sorry, my kid needed to sneeze, and it made me laugh. So data estate and data modernization is the first part that you can take away, just to get just some additional numbers. And there you can have some pathways on how you can move away from that. The only thing that we cannot move really traditionally is Oracle databases, but maybe you can take a look on how you can use other data services to move and migrate away from your Oracle databases, for instance. Yeah, the PostgreSQL, typically we see that Oracle users are moving away to Postgres databases, and because they have all the features that Oracle databases also have. But there's also migration paths for Teradata and DB2, for instance. So there, it doesn't limit yourself to SQL servers alone. Okay. Then we have another layer inside of the migration approach, which is the middleware. This is a little bit more trickier because typically in the middleware we have something like it's a self-written APIs, it's Windows services that are running somewhere. It's going to be harder. But try to look at any kind of PaaS platforms that we have today, because a lot of people don't realize, like for instance, oh yeah, I've written a .NET framework WCF service. I cannot rehost that. Actually, you can, because WCF only needs an IIS, and what's the best landing zone for an IIS? That's an app service. And you can actually run WCF inside of app services, so you can move that away. If you're using an orchestrator, take a look on what kind of features that you need and how complex that is. If it's not that complex, maybe you can just easily rewrite those in functions and call the functions part. Right? But also maybe try to automate with Event Grid or Logic Apps, for instance. Logic Apps is actually the best dog in the cloud. Right? And if you're needing to have some SSIS, you can have ADF in place. ADF or Azure Data Factory will help you to move data and to do ETLing, which is typically part of the middleware that a lot of people are talking about. If it's all ticked, maybe also start thinking about rewriting those, all the frameworks, all the languages, taking them out of the equation and rewrite them into newer parts. And if you need on-prem integration, which is also possible, think about things like Azure SQL Relay, Azure Relay, I mean, or take a look at hybrid connections. And they're very open, and they use WebSockets underneath, and they can just connect basically anything without even opening firewalls or even going beyond additional infrastructure. Because typically, if you still have on-prem, you also have people involved on the networking stack, right? The only thing that you should take a look at is batch computing. So if you have a lot of calculations in the end, maybe take a look at scale then, because that will typically be harder to move. Or look at Azure Batch for that, which also uses scale sets for your jobs, and you can have any kind of image pointed back to that. So that's a little bit the thing that you can do here for the middleware approach. As I mentioned, app services is a very good landing zone for a lot of these things, and you can even just use it for your own estate, like EAP, for instance, for the entire Java JBoss. All these things can be hosted into app services. So this is something that you might take a look at when you're moving away. Now, the front and the back end migration layers these are the easiest part. The front end, typically, if it runs in IIS or Apache, app service is your friend. If that's not sufficient, you can always put it into a container and just use it on an app service with containers behind it. Or even take a look at Azure Static Pages support. And that doesn't always have to be Azure Static Web Pages on Azure App Services. It can also be just storage. I don't know whether you know, but a lot of people don't know that in Azure Storage Accounts, you have this feature of web enabling static web pages in there, just by a flip of the switch or just with one single AZ CLI command. And this is really, really cool because it can easily just be a highly available web hosting for static web pages, with the advantage that you have CDN in place, which is making it globally available for everyone with a low latency. It has no behind the scenes gears. You have no running operations there, and everything else can just be repointed to Azure Functions or just a an ACI or an ACA if you want that. So an Azure Container Instance, or even container applications for that matter, and just exposing a small APIs through that. So you can easily move those away. All right. So that will bring you some value inside of your services. We, as I mentioned, you can easily test those things. Just try deploying immediately from Visual Studio. I know friends don't let friends right-click and publish to application services. You should never do that. You should always go for CI/CD approach with DevOps or with GitHub or whatever you have. But you can easily test this and see whether your application is already compatible and whether it can work with the deployment. And you can just use the web deploy features or the Webpack features from within Visual Studio and just deploy that way. And it will typically stay the same, whether it's an IIS VM or whether it's a web app, because you still have IIS. And for those who don't know, if you ever want to test all the IIS capabilities specifically inside of app service, you can easily do that by going to the Kudu endpoint. Yeah? So if you have an app service, there's this specific tools that you can use, and maybe I can show you that. It's always better to show you what I mean. So I can go to my portal, and I can just do just go to a website that I have. So I have here a website that I'm hosting, which is a SonarCube website. This is just my web endpoint, you know, Azure Web Sites.net. That's the fully qualified name for Azure websites. But if you go in between the name of your application and the Azure Websites.net and you just place .scm, which stands for Source Control Management, this will bring you to the Kudu endpoint. And Kudu is a behind-the-scenes service which is opening up all the service extensions for your application app service. And here you can actually just interact with everything from a command line. You can just drag and drop all your source files, your web packs, your jar files. They will be unzipped immediately if you have them. But here you can also take a look on what kind of processes are running. If you do a get process, here you will actually see that this is running IIS because you're running immediately on W3P. And you can interact with the W3P and have all the loggings there, but you can easily just take a look at them from here and take a look at all the diagnostics dump. And so now these have been exposed also through the Azure portal. If you take a look here, they do PX Sonar. There we are. So it's this one. These are also being exposed into our application services blades as we know them here. Typically, you have them here. But there's still a little bit more interactions that you can do here too, especially when running like command line interfaces and all these things and running some PowerShell scripts. You can actually do those from here out. And you can do a lot of interactions from here out. So this will give you a backend, and this is actually interacting with the IIS immediately. And it also gives you all the environment variables back, what you're running on, and you can see what it is running on and what kind of the environments are being set up in all the little scopes that you have for this environment. Okay, so this is Kudu, and use it at your convenience because it will help you troubleshoot whether you have something which is totally unrelated or totally incompatible with just a normal running application on IIS. Right. We have some tools for that to help you migrate your application. You can do this easily with the application migration assistant. This will just scan your environment with either with an agent on premise or just of the endpoint that you have. And this will allow you to get a better assessment whether this will be compatible with just application services. So this will help you. Also think about other services to run your environments too, because it's not only .NET or Java, but also think about things that are already on premise, which is Spring, for instance, Spring Boot applications. If you're a Java developer, don't forget Spring is being used by almost 60% of all Java developers as a microservices framework, which is already existing for a long time. Yeah? We just can run that natively inside of inside of Azure on something we call Azure Spring Boot. Okay, so take a look at those if you're running those applications already today. Any questions on the migration path?
None from my side, Mike.
Okay, okay, good. Still interesting, people?
Yes.
All right, go, go, go. If I'm going too fast or something, just yell. Don't start there. You can start throwing with things. It cannot hit me anyway, so that's okay. All right, let's talk about greenfield. So if you want to build new solutions, what are the things that you need to keep in mind when you're talking about building for resiliency? Now, first of all, don't overcomplexify, nor underestimate what you're doing. This is very important when designing for failure. Because if you overcomplexify, you will make it harder for yourself to manage everything in the end. And typically, you will not reach your resiliency or your design for failure because there's too many other things that are impacted. But you need to keep in mind things like design patterns. You need to keep in mind the technology choices that you have, some avoidance. And most important is where all the failure parts are lying, right? Because this is typically you need to do some risk assessment and you need to do some analysis on what moving parts can fail and what will bring down your entire system. And you typically don't want to go into cascading because if one service fails, all the others will fail too. So this is typically something that you want to avoid. So you want to make sure that every single layer can be is designed for failing and scaling separately. Yeah, I'm going to give you some principles along with this, which will help you into looking into those. So let's first think before we are acting. So the pitfall is that a lot of people are still thinking in a monolith way in legacy. And they also think that they need everything like they used to do it on premise. Oh, we need heavy networking. We need this, we need that, which is wrong because you have so many services today available that are taking away most of the burden that is already there. And that's why we're also looking at frameworks and stuff because it makes our developer life a little bit easier. And we have a lot of choices there that we can make there too. And that typically seems a little bit more easy because developers are a little bit more agile to that. But when it comes down to operations and managing infrastructure, that's a different story. Okay, so the solution here is to think in layers, not only in tiers, but also in layers, right? And as I mentioned, don't do networking design. Now, is networking bad in Azure? No, because you will typically need some of that networking interaction to make it more robust and more locked down from the rest of the world, but it all depends on your requirements. But most important is that you forget what you know and learn to cope with all the new capabilities which we have at our disposal in things like cloud. Now let's first take a look at something which is really dear to me, which is what we call inter-service communication. And typically you have interactions immediately on services. So service A talks to service B and service B talks to service C, and there's never typically an interaction between A and C, right? If service C drops away, you will probably, if you did a bad design, you will probably have a cascading back error, and there will not be a transient fault error here, and your service will A will fail, which is bad. But what if you don't have a response back, what if you could just do an design for that? And one of the patterns that we can use in here is cascading retries and circuit breaking. So if you have circuit breakers, they will probably block off the services that are failing and giving back either a positive or a negative result back to your inter-services, and all your other services will keep working. Now, some of the designs that you can do here is make sure that you have patterning with either with service meshes or with messaging. Service meshes are the easiest because the frameworks around the service mesh will actually make that that link that you have there non-hard. Each of the services just are calling to a service, whether it's there or not. with a messaging interface, you will have it a little bit different, where you can have a message being pushed on a message queue or an event source, and this is where your service will then pick up. And if they're not there, don't worry, the queue will just live on, or it will go into the little queue it stayed so long, and can be picked up afterwards. So your other systems will be a sync. Your other systems will not be impacted by uptime or by downtime, which is very important. Service meshes also give you the capability of being distributed. You can distribute your components everywhere, and it's a single business transaction, but it doesn't matter where they are doing. And they can scale on all different levels, because it doesn't matter how many you have. Each of the services can live on, and this is where microservice design comes in. Yeah? But that doesn't have to be the end goal. Right? But take a look at them if you can use them. No. So, and when we talk about scaling, and this is typically for a microservices design. When we talk about scaling, we typically look at all the features that we have inside of Kubernetes. This is something which comes up a lot when we're doing microservices design. Again, it shouldn't be, it shouldn't be the ultimate goal to have a microservice design. You can have a partial microservice design, and you don't have to run it on Kubernetes to be microservices. And don't let them fool you. But use the features that these services have. Let's say, for instance, Autoscale, Azure Autoscale. We have a lot of services that are using Autoscale. Autoscale is a service which is being used inside of a couple of services, and it's part of Azure Monitor. So Autoscale can be used in app service, for instance, by means of rules that you determine on VM scale set, but also works on Spring Cloud and so on and so on. So there's it's not a lot of services that have auto-scaling enabled, but if you can use them wisely, because it's not only scaling up, it's also scaling down, taking care of the elasticity that is behind it. Now, the easier way of doing scaling is, of course, in Kubernetes, as I already mentioned. Today, we even have a managed Kubernetes environment called Azure Container Applications, which is just a full obfuscated Kubernetes environment where you can deploy your applications inside of containers. But we do all the management of Kubernetes, and you just focus on the application. So no need to learn kubectl, no need to learn everything on Kubernetes metrics and stuff. We can just use those. And with those, we also implemented a couple of features like the usage of Kida, which I will talk about in a second, the usage of some other services. And we also use the Kubernetes scaling APIs in there. So horizontal pod scaling, the node scaling, which is vertically, and so on and so on. So use those scaling features. There's even some extensions that you can use, and I'm going to talk about these now, which will either implement some patterns or will just implement some other services to go on to. You can read about all these different scaling and design principles in the architecture center, as I mentioned, and circuit breaker, but also singularity and so on, making it sure that your services are there. And it will typically dribble down to something what we call the well-architected framework. And for those who don't know what the well-architected framework is, it's about 5 pillars. All of the major clouds have a well-architected framework. The only difference with the other well-architected frameworks from the other clouds is that the AWS one also has 5 pillars. The Alibaba one also has 5 pillars. Google only has 4 because they integrate, I think, operational excellence and performance efficiency, or performance efficiency and reliability in one. So that's the only difference, but they all come down to the same principles. And these 5 pillars are about cost optimization, operational excellence, performance efficiency, reliability, and security. Typically focusing on where operational excellence will allow you to do A/B testing and deployment monitoring and monitoring itself, where the performance efficiency is making sure that it can scale in an elastic way, and reliability is the resilience and the high availability factor. We also have the cost optimization here because a lot of customers and partners are focusing on, yeah, my bill is a little bit high. You never can have either of these all together, or you can, but then you pay a high cost. So there's always some trade-offs that you need to do when you're talking about a well-architected. Yeah, I want to have everything secure. Okay, if you want to have everything secure, your cost will go up. Yeah, but then I cannot cost optimize. Yep, it's a choice. And typically, it's like a three-legged stool, right? You can only have two instead of three. Right, just to give you an idea. All right, back to the principal part then. I talked about service meshes, and there's a lot of them out there today. It's and everything which is being based upon a service mesh interface, which is an open standard, can be used as a service mesh. And the most well-known are things like Istio and Linkerd, but also Microsoft, we have our own, something called Open Service Mesh. This is something we gave back to the CNCF and is now already, it's an incubated project, I think. Don't take me on the naming of CFCF based projects. But what we did here is we are building new ways of doing observability, but also security and intercommunication of services, and adding to that world. So this, we build upon the SMI standard, and we're bringing back an open source standard to make sure that your service can benefit from. And one of the things that you can use open service mesh with is Dapper. Dapper is a distributed application runtime allowing you to build your services and your applications with a sidecar implementation. So easily injecting new services inside of that part. And with OSM injected, you will actually don't have to worry about the communication between those services because Dapper will arrange it through OSM, and making sure that service A can talk to service B without having to point to a certain IP address, a fully qualified name. It's just it's just like on a football field, right? On a soccer field, you have 11 players on there, and everybody knows that he's the back. That one is the attacker. That one is in the defense, and we know what kind of roles everybody's playing. And if that person is being replaced by another person, you still know that that person is functioning as a back, as an attacker or whatever. I'm not a big soccer knowledge, so so don't shoot me on that one. But you get the idea. People know what kind of a role everybody's playing. It's the same with Dapper. I want to talk to that service. That service will just reply, and you can take a look at it as an actor-based build system combined with OM, which is an open application model. This will help you to build more resilient services, and which can scale independently on all the service levels, because that is built in from that model. So if you're interested in that, look into Dapper and see what you can do with that, whether it's with .NET, whether it's with Java, whether it's with Go and Python. You can have support for all these different languages if you know them. I don't know what your developer backgrounds are, but at least you have a plethora of choices that you can take a look at. Bringing it back a second to the Kubernetes part. There's one thing that I really want to focus on. Is something called KIDA. KIDA is helping you scale on anything which can be event driven. So KIDA is short for Kubernetes Event-Driven Autoscaling, which will help you scale your environments, your application environments, which we have deployed through Dapper, for instance, inside of Kubernetes, and making it sure that it can scale and also have the health care features of Kubernetes in interacting with it. So imagine that you have designed your services to be going over a messaging interface, having an async waiting, making sure that your service can pick those up, but they also need to scale because if that queue is growing. Let's say, for instance, you cannot predict what kind of load you will have on your services. So let's go for the big store thing, right? And you're doing a promotion, you kind of expect that there's going to be a little bit Who knows? It's a new product. Nobody cared, right? And all of a sudden, it's not like 10 times the load that you expected, but it's 1,000 times the load that you expected. Now, Kita can help you here. So let's imagine that all of a sudden you have 10,000 people buying your product and they're all doing it at the same time, but your system is only calculated for like 100 people. Then you're going to have a problem and you're going to throttle down your system. Now, Kita, what it does is if you write back all your orders into a message queue or to an event hub or a Kafka or a RabbitMQ or whatever you have, any kind of system that is supporting Kita, Kita can take a look at the metrics that are being pushed inside of that event-driven base and making all your different pods and containers scale accordingly. So if it sees that there's all of a sudden 10,000 users or 10,000 calls extra, it will scale, let's say, based upon the heuristics of the telemetry, it will scale an additional 20 pods, for instance. And this will allow you to have a very high available and very scalable and elastic system. If the queue is empty, Kita will scale down to 0 and making sure that your system can be throttled down again. So you don't have to worry about it, all by using the Kubernetes health APIs and the interaction with the messaging interface. So this is a little bit how it works. So you have a message. Let me just show you this. You have a messaging interface. You have some event sourcing, and the event adapter will actually making the scaling work well. So and this will give you multiple deployments already on deployments that it knows. So you don't have to worry about it. And it works on the metrics API and the health platform application. Okay. Another thing that we look at when we're doing greenfield, because we're still talking about greenfield development, is try to reuse as much as possible of things that are already existing than writing your own. So look at things like logic apps, for instance. There's connectors for systems all over the place. Try to benefit from that. Look at things like event grids, but also take a look at other SaaS options. I want to have a fully functional, scalable Kafka solution. Yeah, you can build it your own, and you could deploy it in a Kubernetes, which is a worst practice, by the way, because there's two things that you better don't push into a Kubernetes environment, which are databases and which are messaging interfaces. Because if something fails there, your master will need to be built up again. And this is kind of painful when you're doing a redeployment. So that's typically something you try to avoid. Yeah? So you use that as a service. Now, if you want to use Kafka in a very scalable way, you could use Kafka on Event Hub, for instance, but maybe you can also take a look at a third-party service like, let's say, Confluent, which has that, which is a very scalable Kafka integration. And you can just, yes? Okay, I thought there was a question. So there's that. Or use SendGrid, for instance, for mailing interfaces or things like that. So don't write them again and something that needs to scale. Use Twilio for messaging for sending SMSs. There's a lot of SaaS systems that you can use and inject inside of your Azure solutions, right? So use instead of writing them themselves, and take a look at those. And only do wiring for the things that I'm mentioning here, which is a very important thing. Never do this and build your own identity system, for instance. Always use something which is pre-existing. My identity is a weakness inside of every system. It can be the key to your environment and even to the key to your infrastructure. Yeah? So you're never going to do oh yeah, I'm going to build my own identity management system and I'm just going to push all my users and all my passwords inside of a database. If I see you doing that, I am allowed to shoot you, basically, because that's the worst thing you can do. You don't want to be the next service which got all their users and their passwords exposed, and you really don't want to be a clear password offender. Okay, so this is something you really try to avoid at all costs. But use things like AAD for your identity management system. Use things like Identity Server or even Okta or Auth0. Okta had a little bit of a bad thing this week because they were exposed as breached. I don't know whether that's fully true, yes or no, but they were in a bad news. But still, it's still a lot safer than doing it yourself. Yeah? And even for the authentication and authorization part, there's a lot of services that you can use or reuse. AAD has a good API, but we also have an MSAL, so an SDK for that, for doing those things. Right. And integrations, there's only one thing that I want to say here: never do FTP. And if you need to do FTP, then you use FTP on blob storage and you use that. But you're not going to set up your own FTP server. FTP is the worst protocol ever. It's the most unsafe protocol that ever existed. So keep that in mind. Don't do that. And if you do need to use those things, make sure that you can do it in a more secure way with SFTP on Azure Blob Storage, which you can monitor better. But for everything else, use APIs, use messaging, PubSub, Blob, use things like logic apps and have an integration there. Use Relay, use hybrid connections, and do the integrations like that, which will make your life a little bit easier. Okay, taking a look at time, some of the things that can help you into greenfield solutions. So first of all, as I already mentioned, app service. That's an important one. It can be used for a lot of things, even for PubSub or WCF running. Yeah, and it can you can benefit from a lot of things here. So I'm quickly going to go over that. Functions, durable functions, making sure that you can orchestrate here, fanning out. Making sure that you have some state here and having long-term running functions. You can do those and taking away a lot of the container workloads that you might foresee and do some work there. Yeah. The beauty about functions is that they have a lot of connectors and a lot of easy integrations with other services in Azure, and they're quickly installable microservices without having to look at a lot of infrastructure because they're serverless, right? There's no servers there. Virtually there are, but you get the idea, right? And take a look at all the different things that you have, and you can even use them for background tasks. So making it more and easier for you to manage all these little things. So it's really as a function microservice that you can do. So you don't have to invest a lot into expensive infrastructure as Kubernetes, because no matter how you look at it, even AKS is still an expensive infrastructure that you need to manage. It's not a PaaS service, it's really infrastructure as a service, because there's still a lot of VM work underneath the covers, but you don't worry about it because we do the management of those. But you still have to worry about the nodes, you still have to worry about the kubectl and all the actions that are happening there. So maybe functions could be a good replacement for all these different features. And you can even use functions with Kida, with Azure Virtual Nodes, or just integrate them with Kubernetes and making sure that the scaling happens there instead of the Kubernetes environment itself. To making it more globally available, your service, which is also part of the resiliency fact, is that you need to have multi-region applications. And if you have multi-region, that means that you need to have some load balancing features in between. Now, in the past, we only had things like Traffic Manager, and Traffic Manager is a very stable and a very cool service which allows you global availability. But it is lacking a couple of things because it is only doing the balancing part on the on DNS and on IP based. Front door goes a little bit further. You have the same capabilities as in Traffic Manager, but it also brings you API acceleration. It brings you CDN out of the box, and things like integrated SSL offloading, web application firewalling, and DDoS protection. Yeah? So it even stands as a security base, and it easily can integrate with any kind of endpoint that you have, but most specifically with app services and static web apps. You have routing in there, you can have all these features, and allowing you to even have failover policies written inside of your environment. Combine that with CDN, you have a globally available system. Still, you have to do some regional deployments, but it will limit itself only to the application services that are running and no longer to your storage, because CDN will actually take that over, right? And since we're talking about the storage level, don't forget about Cosmos DB in the backend. Today, if you're designing a new greenfield system and you don't need any real relational data, take a look at Cosmos DB and take a look at all the features Cosmos DB can bring you. Now, the hardest part here is how to decide on these features. Well, depending on the endpoint that you need, you either go with any of the APIs, but typically, and this is how Cosmos DB was designed, and a lot of people don't know that, is typically we offer standard the SQL API, and which will give you all the interactions and all of the features, because not all of the other APIs involve all the features of Cosmos DB or Document DB underneath. The other are they're more to support you in migrating legacy or other environments easier to give you more leverage just with a flip of the backend to move or migrate to a more scalable system. Now, if you want to have some graph APIs, you can still use Gremlin, of course. And if you want to have some specific MongoDB features, you can still use MongoDB. But my advice, always go for the SQL API. Now, you know that Cosmos DB is a global master, meaning that everything can point back to one single database and it can write back to any other region at the same time and replicate itself without having all these replication issues. But it does depend on the consistency model that you implemented, and there's 5 of them, going from strong to eventual consistency with 3 other levels in between. And this will actually decide on how globally available your application will be too. And the choices that you made there are eventually also important for everything which comes down to your resiliency and to your backup strategy. Because if you don't have if you have a strong consistency, your backup will be a little bit more better. But if it's eventual consistency, you will have a stronger and a faster access to the other replicated sites, but the data will not be as consistent as can be. Yeah, so your backups will probably not be the best backups overall. So there's a lot of strategy to be involved here, but you get a lot of leverage. Again, this is a globally distributed architecture that you can take a look at, multiple regions, have traffic manager and front door in front of that, and just talk to one single endpoint, Cosmos DB, and we handle the everything else behind the scenes. Okay, so this is on that level. Some other microservice micro architectures done differently. This is some other architecture, but if you want to take a look at a good global distributed example of low-level services giving you like static web pages, like functions, like front door, and all combined, take a look at the URL list. This is a nice reference case, which is being built by 2 guys at Microsoft, Burke Holland and I think it was Cecil Phillips. What they did here is they used front door as the landing zone, and everything else was just websites on storage, some static websites, and some functions behind the scenes and Cosmos DB to have a globally distributed system run on the price of a coffee per month. So, and I mean a Starbucks coffee, so expensive coffee, right? But it's still very cheap. And very highly available, very resilient, but also speedy, very performant, and very low latency accessible. There's some other highly scalable and resilient multi-region architectures inside of the architecture services and architecture center that you can take a look at. But this is another example of how to use Kubernetes, for instance, which makes it a little bit harder to do because multi-region Kubernetes is very hard. You need a lot of replication in there, specifically on the configuration part, but you get the idea, right? Other things that you need to take into account when you're doing greenfield design is everything inside of integrations. And there's a couple of services that you can use here to make your services more resilient from that point of view. Of course, there's API management, but also give some love to things like Event Grid. Event Grid is such an underestimated an underloved service. It can almost automate everything, and it will be the savior of your solutions to do backend automation or even automation for some of the things that you're willing to do with your customers, for instance, right? Let's say resizing of images. Just use an event grid for that, hook it up to the storage account, making it sure that it can immediately interact on it. And with storage, it's very specific because it's an immediately hook inside of the storage account because it's built on top of that. And you can immediately have those scenarios at your disposal without having too much hassle and setting up a lot of functions and all these things. Some of the scenarios that you have here that you can take a look at of all the integrations is you have a lot of triggers on one side and a lot of actions on the other side that you can have or that you can play with, and it does limit here. There's more and more services coming with event grid support. This is this is a scenario, for instance, of resizing all your images that you have in a storage account. So an event grid automation. API management, which I already mentioned. Why is this important? API management gives you the scaling, but also the high availability of your APIs as an endpoint, because API management will actually leverage the throttling of your APIs. So it can not only be used to have a subscription on your API and saying, I have a freemium subscription where you can only have like 5,000 calls to my API, but it can also be used to block all the malicious traffic, which is trying to DDoS your services and making sure that it goes down. As an enterprise, this is something that you don't want. And it adds more to it. You have key vault integration, you have all these service integration. It even interacts with event grids, and you can do automations there. It can be a front end for your microservices and your APIs that you already have. You have versioning, you have good developer interaction there. But most importantly is that scalability along with it. And today you can host your API gateway almost everywhere. So it doesn't matter, even on-prem, self-hosted, and it lowers down the price also. So keep that into account. That is something that you need from that point of view. What else do we have? Some other looking at, yeah, okay. Some topologies that we have. This is yeah, with API management, some topologies. So you have a traffic manager which will call to secondary and the primary state, and depending on where the people are coming from, they will be routed to that location. And you can even do that in a multi-region, multi-global environment. This is top notch, but it costs some money, right? So. Logic apps, I mentioned them a lot of times already. It can be scalable too. It can be used to design your logic apps in a graphical way, but it has a flat cost. And the cool thing about it is everything is isolated too. You can connect it into VNets. You can even have a full hub spoke topology injected there. So you can do a lot of things with the integration service environments. Giving you a dedicated way of handling integrations in the backend. So this is something that you don't need to build yourself anymore. Okay, that brings us to the final part of the integration services, which is something called service bus. And service bus, again, a lot of features in service bus which are being built on. It's not only the base service for everything which is Event Hub and IoT Hub, but it also is being used for notification hubs, topics, queues, and relay. As I mentioned, relay is pretty cool because it is using NAT and firewall traversal without opening any ports. It can just talk to any kind of service over HTTP and HTTPS. But you can even use it for AMQP, MQTT, traditional Oasis standard messaging interfaces, Event Hub with cloud events and all these things enabled on there, making it very scalable. And the premium SKUs, they also have an offloading mechanism in which you can have a failed state. You can even write back on the service buses, which comes with an additional cost, but you can then replay. So there's a high availability there too. Yeah, so this is all the things that you can have. So take a look at these services to make your all your service interactions loosely coupled. Yeah, this is what you should focus on. A little bit more on relay here. All right, chapter 4. This is the last part. and this is going to be a little bit shorter part. Yeah. The thing is that it's not only about building your services, but it's keeping them up and running too. Now, if you have a multi-region deployment with inter-service scalability and inter-service level failure designed, and like message buses and all these things in between, still things can go wrong because you still need to update those things. And remember, fault domains and update domains. Now, most services are using those, but what if you didn't actually keep that into account, right? So this is where DevOps comes in. DevOps will give you an additional element of high availability and resiliency if you do it well. Yeah? And for this, we need to take a look on why bad things happen. Typically, is because things are failing, hardware fails, whatever, bad disks. Yeah? But software will also have bugs, yeah? And people will make mistakes. These are typically the things why things are happening, right? So there's a lot of layers of defense that we try to build in, and there's still accidents that can happen because everything passes through the loopholes. Yeah? So DevOps is an approach and a culture that you're building into, but it also has something that that practice brings along. It is that it is mostly built on top of automation, and it's also built on learning. It's not a practice. It's not a role, I mean. So if you're a DevOps engineer, sorry, that role doesn't exist. It's a practice and it's a collaboration feature. And it's also about automation, and it's also about monitoring. It's also about all these things that everybody is doing inside of an organization, which is impacting on software development. So everybody has a part. One of the important parts that we have here is infrastructure as code. Try to build your code as infrastructure. Try to build your infrastructure as code and making sure that you can just easily redeploy and use that as a backup in disaster recovery. But you can also use that to make sure that everything stays in sync and that you have a desired state configuration of your environment, of your infrastructure, and automate this to the max. So this is an important. A little reading of infrastructure as code, it actually comes down to that you have a definition of your infrastructure, and that you can update it every single time that you do a deployment of your application. So you don't only deploy your application, you also every single time deploy your infrastructure. Why is this important? Because you want to test against all the practices that you're doing, but also want to make sure that your infrastructure always stays as clean and as neat as possible. It's declarative typically. It's a single source of code, and it can be used as a failover mechanism. We have a lot of things going on there in the infrastructure as code part. First of all, we have ARM templates, which is infra as code, as good as, but a lot of people don't like the JSON dialect. And to be honest, I have a love-hate relationship with JSON because it never does what I do. I'm very proficient in ARM templates, but there's still always some things that I tend to forget, like the long subscription and the long resource URIs and all these things and all the resource GUIDs that you need to have. And therefore, we build up something which is called Project Bicep, and Bicep is getting more and more leverage inside of the Azure world. So it's on based up it's a DSL on top of ARM. It can still generate ARM, and it comes down with some dependency checks. It comes down with some infrastructure as code checking, and so on and so on. So it has some additional features that can go along with it. It's a CLI that you can install, but you can easily implement this inside of GitHub Actions, for instance, or inside of Azure DevOps. Okay. We also have Terraform. Now, nothing wrong with Terraform except for the false promise that it is fully multi-cloud. None of the tools that you have for doing EAC are fully multi-cloud. Whether it's Terraform, whether it's Pulumi, you always have different resource providers, and you always have different resources, because an AWS storage account is not the same as an Azure storage account, because we are based on Blob and they are based on S3. So that's a totally different approach. Yeah? So you need a total different storage provider for that. Yeah. So you will have totally different scripts. The upside is that you have one language which can be used for all these clouds. That's true, and that's not a false given. That's an advantage that we have. So it's a little bit of choice. So either you do is good. doesn't matter. But the most important thing is that you have a definition of all your infrastructure as code, and that your developers as well as your operations people are working on this to see how they can leverage all the benefits of infrastructure as code, because they can inject like routings immediately, they can inject like security features immediately, policies, and so on and so on. So this is something very, very important. So what it is, it's not write once, deploy anywhere. It does do that when you're staying inside of the same cloud, but it's an abstraction layer that you're doing. Okay, so a little bit of a difference on DevOps and GitOps. GitOps is more on the configuration of things, where the DevOps is a full practice, right? I put in a a quote of myself, because a couple of years ago, and that was 2013, I said cloud enforces DevOps. There's no way around it. And Microsoft went, what are you saying? 2018, I started working for Microsoft, and in 2015, they realized, yeah, you were actually right. So there it is. DevOps is something that you need to get along with, because either what you do in Azure, in AWS, you're gonna need it because it will help save your life. And for these reasons, I'm gonna go over these for a single thing for a moment. So there's a couple of other readings for you here, some safe practice deployment things. But the thing I want to focus on here is how you can use DevOps to keep a system high available. Yeah. Typically, we talk here about ring deployment, capability deployments, opt-ins, hot fixing, and all these things, service isolations stuff. And one of the first things that you're looking at is feature flags. Feature flags can be enabled into code and making sure that your service doesn't go down, even if you have breaking changes, which is really, really cool. Why is this so important? Because feature flags can be enabled to something which we call today app configuration in Azure. You can also do this just in code, but app configuration actually has a full stack enabled there, where you can see the feature flags immediately popping up from a configuration point of view. And you can enable that feature flag, yes or no, just by going to the Azure portal. So your developers and your operations people are into control when it comes down to deploying new features. Even if the feature is not fully implemented, as long as that Boolean, because that's basically that if statement isn't being triggered and going into that line of code, your code will stay alive, right? Service isolation, making sure that each of the services are being isolated and that they don't have a cascade on top of that. This will give you high availability and high resiliency of your services too, because one service cannot take down the other. Making sure that you have rollback. Think about Canary and AB and green and blue releases. Yeah? These are things that we have also in app services. If you do an app service and you have deployment slots, you will have these capabilities. You deploy it to your staging slot, making sure that you can test it, offload, do some A/B testing on there, do some offloading there. 80% of your people going to the testing and 20% going to the production part. If that is okay, you just do a service swap, a DNS swap, and you're done with it. And this is making sure that you do that. But you can make it even more complex by doing ring deployments. We do that. We have ring 0 where all the main services are, but we also have ring 4, for instance. This is how we do our deployments in Azure. We don't do deployments all at once. We only deploy to rings where you have hero regions, or we have all these things, and making sure that people can start to address them and see if there's anything wrong. Now, of course, we had some issues in the past where we did deployments and the top rack nodes went down. But we have a fail-safe mechanism in there that it will not take down everything else. Remember the isolation, right? If one top rack node goes down, all the others will block itself. Of course, if there's already a deployment going on, then that will be troublesome. We had that a couple of years ago, but we try to avoid it. But this is something that you can do too for your own services if you have a multiple region deployment. And this is a little bit how it works. You can do incremental rollout, and this is how we did it with DFS, for instance. Just for your reading, we can have a little influence here. So I already mentioned A/B testing, blue-green deployments, canary deployments, but also semantic versioning on your APIs, for instance. Use API management and expose all the APIs to your end customer and let them decide on what kind of a version they have. So that way they also are a little bit in control of the breaking of the API and of the high availability of their services that they're building maybe on top of your platform. So that's a little bit on how that works. Yeah. Green-blue deployment, as I already said, the staging slots, as I discussed. And it's not only about that, you also need to make sure that you test that. What if, and I'm not talking about the Disney series, what if something goes wrong, but what if something else would happen? But what if something goes wrong? And this is where chaos engineering, chaos testing comes in. Chaos engineering is where we deliberately are testing against failures and that we're bringing part of our infrastructure down to see whether we're going into the correct direction. And today we have a service that can help you there called Azure Chaos Studio, which will bring down parts of your solution, not really, but blocking all these services and making sure that your service can still be resilient or be recoverable from these failures and from this chaos that is happening. Yeah? And Chaos Studio will allow you to have an agent-based or a service and direct talking to your code and to your infrastructure, and you can do experiments on top of that. You can do this in either a DevOps approach or just in a manual approach if you want to test it deliberately. And you can actually maintain that together with your full CI/CD pipelines to make sure that your infrastructure as code testing will be done before you actually release it inside of production. This will give you the benefit of testing the resilience before you actually go into production. Some other practices, typically for improving security, because it's something also heading up to a higher availability and a better resiliency, is the implementation of the SDL, so a secure development lifecycle. SDL is nothing new. I have a full session on secure DevOps and secure development lifecycle. But make sure that you have things like threat modeling in place, that you do security assessments, but also that you test with DAST and SAST. So static analysis on your code and dynamic analysis on your code, meaning once you deploy, you look for the weaknesses. It's not the same as penetration testing because this is on your production systems, but this is something that you do in runtime during your DevOps CI/CD lifecycle. So you deploy your application and test, and you have an automated system that will actually test for all the weaknesses coming back from your runtime, not from your code coverage. Okay. Do some scanning on credentials, secrets, and all these things. We have tools that can help you there. GitHub Advanced Security, for instance, allows you to do SAST scanning, allows you to do dependency management, allows you to do secure deployments by means of secure integrations and listening to the policies that are behind it. Threat modeling is something which we offer as TMT, for instance, a threat modeling tool, which is a free tool that you can use for threat modeling. And there's also Threats Manager, which is a Threats Management Studio, which is also being built by a Microsoft engineer, but it's open source and you can just use that. That's pretty cool stuff. And this will bring you a DevOps practice to improve your security, but also your high availability of your services, of course, in multiple regions and with EAC and in control and so on and so on. There's some more reading here. Very important here are also gating, making sure that you have still some human interaction there. Quality control, still important for your resiliency, because if you deploy something and you see that the release is actually failing, but you still deploy, it's not good, right? And it can be fully part of the feedback loop too. Feedback is very important. Whether it's your operations, whether it's your end users, whether it's your development, you have a continuous feedback loop that you need to implement. Now, you also need to monitor for the reliability, as I mentioned, and this can be done in multiple ways. Azure Monitor is your friend, but there's a lot of tools that you can have here. There's Service Health, for instance. There's things like governance, with management groups, but also with policies and blueprints. This is also monitoring, because you monitor the quality of your infrastructure as code after it's been deployed or even before it's been deployed. If your infrastructure as code doesn't comply with the policies that you have, your deployment will fail, which is good because it will not bring down the quality of your system, and it will not bring your entire system, right? And you can use a lot of resources here. Some of the things that you have here is Azure Governance with policy engines, which policy can be used for compliance, but also for automation and for security. And just leave these to your readings, but do note that they have an impact inside of your DevOps culture, right? And you can use them for monitoring as well. What I am going to show you still is some tools that will help you there, and that we're done for the day. First of all, we have a pre-check that you can do during your CI/CD pipeline with PS rule for Azure. This is an injection that you can do inside of any of your DevOps environments, whether it's with PowerShell scripting, whether it's with Azure DevOps, or whether it's with GitHub Actions. There's an action specifically for that. There's a build step for that with Azure DevOps, but there's just also PS rule as an extension in PowerShell, which you can use and build those. This will trigger all the different deployments that you're doing, either pre-deployment or post-deployment, and looking at all the rules that you have on the governmental part, whether your infrastructure as code is fully compliant or whether it will be doing a good job, yes or no. This is one thing. Now, this is all when building it yourself, but we also have a set that you can use, and it's an open source thing. You can find it on GitHub, which allows you to do an always on with everything that I explained here in this session, which allows you to have a kind of related to cloud adoption framework landing zone, defining you an always on environment, which is resilient, high available, and elastic, all in one. And this is just a toolkit that we have. It's a full deployment vehicle, as we call it. It's an ARM template that you can use, allowing you to have an always on or an Azure mission critical, because that's the new name. Always on was the previous name, hence why I put them all on here. With all the architectural patterns that we described here being implemented. The cool thing is, I'm just going to go over that asset. I had some more slides were available. What it does, it deploys a global resource group with some global infrastructure, as you can see here, Cosmos, identity, but also ACR, front door, and so on, into global monitoring with action groups and log analytics in top. And then you have a global dashboarding to just monitor all that. And then you have your regional stamps to have low latency and all these things. Even implementing things like Chaos Studio and all these things, and giving you a better SLO and a better availability up to 5 nines. And if you implement this, you will have multiple landing zones here, bringing you back into things like better monitoring globally, multiple hub spoke technologies and topologies at hand, and security monitoring from a global perspective, but also with all the scaling and impact already there, with all the services there. So this is a really cool thing, and this will give you a very good segue and a very good starting point to build a high available and high resilient foundational design for your solutions. Where can you find this? You can find this on aka.ms/alwayson. It's a GitHub repository, as there are so many available. And it will give you a couple of things. First of all, you have all the documentations, but you also have all the different injections here, the online reference implementation, connected reference implementation, talking about multiple things like application design, application platform, health modeling, and so on and so on, the observability, and pointing back to what we call the Azure Architecture Center again, giving you all the different aspects of a highly resilient environment. There's some more references here that I'm giving you as for your reading and some recap, some call to action. There's going to be some resources into the deck. There's all the documentation links in there, so you can start building. You can start building on the world's computer, making your services run everywhere in a very resilient and a fail built way. Yeah, built for failure. That's it. Any questions? You're muted.
It's always during the COVID time. It's always the same situation when somebody's speaking, forgets he's
Yeah,
on the mute,
exactly.
and also, can you
Exactly.
hear me? Yes, only. Yeah.
Yeah, okay. So that was it. I hope you enjoyed it. I hope you
That's
found it useful.
very, very interesting. Very interesting.
Yeah.
Yeah.
And anybody questions? You can
Yes.
feel free to unmute. So
Yeah. I have a question in terms of you were saying about if you want to do like identity management, you say you're gonna build your own identity management.
mhm. No,
And
don't
it's
build
like you
it.
say,
Don't build it.
don't build it. Yeah, you say don't build it. Yeah, it's like
Yeah.
I'm allowed to shoot you, like you said,
Yeah.
to shoot the person.
Yeah.
So the question is, um, in terms of best practices, are you saying that it's better off using out of the shell identity management from companies like Microsoft than building your own?
Yes. Yes. But you can still build your own ruling engine on top of that and your own flows. That's okay. But use the mechanisms that these companies provide
Okay.
because they can do that in scale, and they are certified for it. They have trust agencies on top of that, so there's a lot more where that came from, right? And
Yes.
they can do that without even knowing what's in there. They have no clue on tokens, they have no clue on identities, they have no clue on passwords, which is good. If you're reusing some of these elements, it will even make it easier for you to integrate other identity providers, for instance, and you don't have to fiddle around with it. But don't go inventing your own username, password combos, and just encrypt them inside of a database, because that's the worst thing that you can do. It's always better to have somebody else manage it, and even better, you put the responsibility of the identity by the end user and not at yourself, because the
Okay.
identity is typically owned by the end user. If you have a
Yes.
Facebook account, you're responsible for the Facebook account and for your password. Yeah? And if
Yes.
you don't set up MFA, it's your problem. But
True.
we can leverage that identity provider, giving you the capability of logging in single sign-on with that identity provider, but you still own your identity, and we have no clue what that identity is.
Yeah. Yeah.
And this is the reason why you should be focusing on using third parties instead of building it your own.
Yes. Makes totally great sense. Thanks.
Okay. Anybody else? You're awfully quiet. I always thought, and with all respect, that I always thought that Africans were a little bit more like, you
More
know,
noisy.
not noisy, no, more enthusiastic.
Enthusiastic.
Yeah.
Enthusiastic. Yeah.
So now, no more questions, people, or I think everybody fell asleep.
No,
Let me
my
check.
so mine is more of commendation. Wonderful presentation, and we really hope to, catch up some other time. Opala, please, maybe by next week, let's see how we can bring Mike in again or some other time. Thank you so
Sure.
much, Mike.
Thank
Definitely.
you. I feel honored.
Nice. Nice.
Hmm. Okay. With that being said, I'm going to give you some of your Saturday back then.
Cool. Cool.
Okay.
Thanks a lot, Mike. It was so interesting. Nice conversation. Nice lecture. I enjoyed it a lot. So it's a pleasure having you here.
Yes.
And
Likewise.
I look forward to having you again in the future. So anytime you feel free, just let me know. I can
Yes.
book you in.
Yes. You can ping me if you say, "Can you do a session on this or on that?" Feel free.
Yes.
I
Cool.
can give you some suggestions, but feel free to think about it. Okay.
Definitely. Thanks a lot.
All right. Bye bye, everybody. Bye bye.
Thanks.
I will give you a link in through LinkedIn on the slide, so that way you can get
Perfect.
them
Yeah.
somewhere. Okay.
Thanks. Yeah. Thank you.
All right. Bye bye.
Good evening. Bye
Bye
bye.
bye.
Ciao. Ciao. Bye, guys. Bye.